Okay, I think we're going. So this is our first problem in a set of 5 problems that we're going to complete together. Now just remember, the first thing we're going to do is spend about 15 minutes on this first problem. Then I'm going to hand out the second one and you're going to spend 10 minutes on that in exam conditions. I just want to emphasize again, remember, yes, we are after the right answer. Of course, we're always after the right answer in maths, but I want to know everything that you're thinking. Remember, you're trying to convince someone who's not familiar with maths that your answer is correct. Now, this is going to be completely driven by you. What I mean by that is that I'm going to help and guide us along to get towards the answer, but you're primarily going to help me get to the answer. So our first problem, week 1 problem, is if 1,236 is divisible by 3, is 6,321 also divisible by 3? Does anyone have any ideas? Alex?
Since 1,236 is in fact making each of the numbers divisible by 3.
Yep.
If you reverse it, then the other numbers are still divisible by 3, and the first 2 numbers, if they are able to be divisible by 3, they've only been flipped around to the last 2, and so 21 is also divisible by 3.
Yep.
Both numbers are divisible.
So what I've taken away from Alex, he's getting on the right track. The main thing I've taken away from Alex's is that 1,236 is 6,321 written backwards. We all agree with that, right? So 1,236 is 6,321 written backwards. If you're not sure what to write down, if you haven't written anything down, make sure you're writing down what I'm writing down. What else do we think, Boston?
Because 6,000, well, the 6 can be divided by 3.
Okay, so 6 divided by 3 is equal to 2, right?
And so is the 3.
3 divided by 3 is 1, yep. So 6 and 3 is divisible by 3. Cool.
The 2 cannot be divided by individually, so you plus 2, you add the 2 and 1 together, so it makes 21.
Okay, so so you reckon 2 combined with 1 is 21, and 21 divided 3 is 7. Okay, let's see if that's going to help us. What do you think, Michaela? Well done, Michaela. So, Michaela has remembered that a couple of weeks ago last term, we learnt about divisibility tests. And the divisibility test for 3, let's remind ourselves, I'm going to write this down. Hopefully I spelt that right. I don't think I did. Test for 3. Michaela, do you remember? Oh, just 1 second. Okay. Michaela, the divisibility test for 3, do you remember what it was?
All the digits.
Yep.
And if what it equals to, if that number is divisible by 3, then the whole number is.
Cool, that's right, well done. So the divisibility test for 3 says if we add up all the digits in the number and the answer is divisible by 3, then the original number that's another divisibility test, Logan. So it actually is, if we add them all up, it's divisible by 3, all right? So, yep, so the divisibility test for 3 we've written down. If we add up all of the digits in a number and the answer is divisible by 3, then the original number is divisible by 3. Now, just to make sure we all got that, can someone remind me what is a digit in a number? Alex?
What do you mean?
in a number, when I say the digits of the number, so what are the digits of 1, 2, 3, 6?
1, 2, 3.
Correct, good. So the digits are those individual numbers. So, Michaela, you were going really well. What were you telling me about 1,236? Someone want to help her? Charlie. What can we specifically say about this number, though? Boston?
Because it's written backwards, it has the same numbers.
Yes, true. But before we get to that, how do I know that this one's divisible by 3, the original one?
You do it.
Eve? 1 plus 2 plus 3 plus 6. What is 1 plus 2 plus 3 plus 6? 12. And is 12 divisible by 3? Okay. Have I answered the question yet?
No.
No, I've written down a lot of stuff. This is really good, but I haven't answered it. What could I say next? Alex, you got your hand up first.
6321 is written backwards.
Yep.
So that means that the digits are exactly the same. So all you have to do is add them together if you want to for fun. And then the answer is going to be the same because the same digits are the same answer.
Right. Now, I'm really happy with that, but I'm not sure I'm convinced that if I add up numbers in a different order, it's always going to be 12. How could I show that? Logan, what do you think?
My thing is with the same numbers. So minus 12 by 6, 3, 2, and 1 to get back down to 0, maybe.
I like that. I didn't think of that. That's a good one. So let's go also 12 minus 6 minus 3 minus 2 minus 1 equals 0. That's a good one, Logan. I didn't even think of that one. And that equals 0. What can we say about that? Therefore, what could I say? Yeah, Layla? Isla? Good. Anything else I could say? Alex?
There is an easy way in my head that you can add these derivative numbers.
Yeah.
So you just search for the two numbers that are divisible by 3.
Mm-hmm.
Whose idea which was 3 and 6.
Yep.
So you cross them out, any number.
Yep.
And then, because that makes the numbers somewhat correct.
Mm-hmm.
And then 2 and 1, which are the remaining digits. It doesn't, you figure out which ways they can be put and which ways they can't put to discern which numbers are divisible by 3.
Mm-hmm.
For 2 and 1, whichever way you put them, they're still going to be.
Yeah, and that's because
by 3.
Is 1 plus 2 always the same as 2 plus 1?
Yes.
Yes. What do you think, Logan?
I think we can also label the therefore sign. The 2 sign doesn't really matter.
Okay, we could say that. Anything else? Any other ideas? We're going really, really well. No? Alex?
If you do 6,000 one way. If you do 6, 3, 2, 1, and then what you do, I believe this is the first way.
Yep.
Is you.
Do you want me to come back to you?
Sure.
Okay, what I was going to add just before we finish, right? What do we think, right? We've said that 1 plus 2 is always the same as 2 plus 1. What about 1 plus 2 plus 3? Is that always the same as 2 plus 3 plus 1 and 3 plus 1 plus 2?
Yes.
Let's write that down. 1 plus 2 plus 3 equals 6. 3 plus 2 plus 1 equals 6. So what can I say about that? Alex?
If the digits are the same,
yep.
then it doesn't matter which order they are in, because they all have the same value.
If the digits are the same,
Then they all have the same value as long as they are only a single digit.
then the order doesn't matter.
Holly, we should also do all digits and symbols are the same.
Okay?
We could change the one between the two and two to a minus. Then it wouldn't be the same.
So let's actually conclude our statement and say, therefore, if 1, 2, 3, 6 is divisible by 3, then so is. Okay. If you haven't written down much, please write down what I've got. I'm not going to remind that of you in future lessons. Okay, now I'm going to just quickly, right, we, up here, we said 6 plus 3 plus 2 plus 1 equals 12, and then I didn't really comment on that. What could I say over here? Alex?
That 6 plus 3 plus 2 plus 1, or any of the other equations that you can do with it, they can actually, it doesn't matter how many digits you have at the end, they're all zeros. So you cannot add other digits that are not a zero. If you add other digits that are a zero,
so you're saying if I add 0 to that number, it's also going to be divisible by 3? Yeah, well done. What I was thinking we could say is we're going to say equals 12, which is divisible by 3. We already knew that, but just make sure we're saying that. Are we okay with that? Okay, I'm going to stop the recording now. We all good? Okay.